Ladies and gentlemen, wonderful people, welcome to this class. This is going to be Winter 2025 FMA exam prep class. But it's wonderful to have you all here. What I'm gonna do, I'll proceed with my introduction really fast. So my introduction. Let's go ahead. My name is Islam Bidir. My students call me Dr. Bidir. So I did my PhD in theoretical physics and my bachelor's in the master's of science also in physics. So all theoretical physics. My journey really started when I was in sixth grade and started with biology of all subject. And I really won the original contests along with my friend. But then later on, I really decided that my passion was physics because in physics you have less things to memorize, more things to build upon. So it's more of like a Legos, right? When you have like a base, you can just put on top of it. So you don't really have to really memorize all this base Legos. So it just goes on top of each other. So in physics, there are really nothing to memorize. I mean, all the equations that come so naturally, so well, explain this beautiful universe in just so cohesive, wonderful way that you just fall in love. And that was my situation. I fell in love with physics, and I decided to go ahead and compete. I was, I think at the beginning of middle school, and then really started. The contests were at the high school level. But from a middle schooler, it was kind of unusual. Nevertheless, I had the opportunity to cover the entire curriculum really fast and then participate with the high schoolers. And maybe it was a chance or luck, I would say. And that year I won the gold medal. And then onward, I really participated again and again among the high schoolers as a middle schooler. And I do see that we'll have some middle schoolers here as well. That's wonderful. It's really exciting to see them as well. And then, and finally, I participated in International Physics Olympiads in 1999. At the time, it was held in Italy. I didn't really have much experimental background at the time because of lack of training in experimental one kind of really took me a bit down. Although in theoretical front, I was really strong and had some unique solutions to offer at international physics. But my background in laboratory was a little bit weak at the time. So next year after that, I really graduated. My student took over and I really knew what to do next. And whom I trained. So he got the he got the gold medal, and then it continued. Afterwards he went to MIT and so on and so forth. So what I would like to really say that is this: FMA was a very pivotal. It was a really turning point for me to kind of get myself into it as a young boy, and then dive into this beautiful world of physics. And then learn more and more. The more I explored, the more I fell in love with the entire physics. Not only really classical physics, but also modern physics, where you get to learn relativity, you get to learn astronomy, you get to learn, gravitation, gravity, and then later on you learn quantum mechanics. That whole story, that whole journey for me really was mesmerizing. And that's why I decided to go to university to do physics major. And after that, I have completed my undergraduate in 3.5. I wanted to squeeze it in 2 years, 4-year college, but professors at the very beginning they held me back. They said, no, you can't do that. You shouldn't be doing this. So I ended up really completing my bachelor's in 3.5. So then I completed my PhD in Virginia in theoretical physics, worked at Jefferson Lab, and then continued to do so. Not at Jefferson Lab, but then switched over. I taught computational physics. Currently, I'm teaching at multiple institutions. I teach physics there and also labs. And one of my passion was computational physics, in which I combine programming in Python along with physics. So, and also I have the labs. And it's really fun because students not only really learn physics, but also at the same time to learn how to program and then fuse them together. So that's one of my really most favorite classes I have taught. And then several years ago, when Momentum asked me if I really wanted to teach FMA, I was sort of totally excited because this was very memorable for me, and I wanted to do something really unique with my students. So now coming to FMA, that's a little bit about me. I have also, just a side note, I also have a background in medical physics, and that's basically it. Just wanted to broaden my knowledge of physics in all fields. As for this class, it's called FMA. Fm equals to ma. Basically, it's the Newtonian equation. Everyone knows it's a very famous one. Pathway to join U.S. Physics Olympiads here in America. It's just simply known as FMA exam. Okay, so it really covers classical mechanics such as Newton's laws, momentum, energy, oscillations, fluids, and then data analysis. It's really wonderful. It's not hard. I shouldn't really say this probably, but it's a little bit intense because the time is very short and limited, and the coverage is really broad. But we're going to really quickly specialize in all of these subjects. Now, what topics we're going to cover? We're going to start from the very beginning, motion, how it really started all, and then Newton's laws, and then we're going to really cover rotational motion, and that really has two components. One, simply rotational motion, and then we'll have rotational dynamics, right? Basically, what causes things to rotate. And then we'll have equilibrium, the momentum, work and energy, how things come together, and how we actually use work and energy problems to solve FMA exam or type problems. Gravity is another thing, fluid mechanics, in which we analyze what happens when you dip something, and what portion is it outside, what portion inside, and then challenging questions, obviously. Oscillation is also very neat and beautiful chapter that everyone really loves. And then finally, we have data analysis. Data analysis, basically, you have a graph, you have plenty of data and things related, and then they want you to simply look at this data and derive some information. That's what we call data analysis. Now, the way we do it is that we're going to start from motion, and then we're going to connect all of them together, and then come out with the data analysis. And I'll be teaching live classes over the Zoom, right? Everything's going to be just one-on-one like this one with my class. And then my expectation from my students to be at least to have a kind of a glance, go over this chapter prior to the class, so that you have an idea what it is if you've never really seen it before. And then if you really studied this, that's even better, because it's going to be second stitch with the problem infused. So the idea here, students will come to the class knowing that chapter inside out, and then are ready to embark into solving some challenging problems in physics, right? And we're going to be doing together. Those problems are mostly going to be derived from the past FMA exam problems, but also I'll be taking from other resources to ensure that students understand that particular subject, if it's motion or if it's oscillations or fluids or whatever the subject is. So we're going to have all this a spreadsheet in which you'll be able to put whatever the chapter you studied, just put the check mark, so I know that everyone really studied and met the expectations. Video recordings and everything is going to be posted in Canvas. So basically classes over the Zoom, and the platform to access all the materials, the homework, all the assignments, and any materials really necessary to master F equals to MA exam are all going to be posted in Canvas. So Momentum has a Canvas LMS, and everyone probably at this time familiar with what Canvas is. You'll have an access to it, and all the recordings if you miss any, or the PDFs or the solutions homework will be all there. Homework will be posted, but also you'll have the access to solutions. So solutions along with the homework problems will be given, so that you're not really, if you're stuck, you can definitely go ahead and look at the solution. And another avenue to master is basically to ask questions. So for that, we can utilize discussion forums in Canvas, so that not only me will be there to answer, but also your classmates, in which it actually enforces everyone to think deeply and try to really solve the problems. What dates? So I unfortunately not available every day due to my clinical duties here in Florida where I live. But I'm mostly available on Saturdays and Tuesdays. And my times, it's so the central time is 7 p.m. Going to start, and it's going to last 2 hours. And these are the full dates. Total, we'll have 12 classes altogether. And then every class is going to cover one topic. I'm going to reserve last 2 or 3 days, perhaps last 2 sessions to do cumulative, like all together, like, not just one particular subject, but just all together. If you were to hit with a real task, what would be the situation like? Okay, such as like a mock exam and things like that. So that will be towards the end. So between these dates, you'll have the opportunity not only to study that particular chapter, but also go over the problems and then solve more problems if you wish to. So that's basically layout. I know some people really do the comment questions. I will come to that in a moment because just I'm unable to check both. Textbooks, there are several, right? One of the really beautiful textbooks I love is basically Physics for Scientists and Engineers by Giancoli. Professor Giancoli put together in a way that needs to be taught. Unfortunately, this textbook, according to the publishers, are not promoted as it deserves because the author is old and doesn't want to actually give the authorship to other people. That's something to do with the publishing systems, and whenever that thing's happening, they just kind of put it down to don't really continue that title. But otherwise, this book is an excellent, physics textbook that simply teaches the physics as it should be taught. So 4th edition, 5th edition. 5th edition is a new one. I couldn't really even find it. And Amazon mentions that there's a 5th edition. I haven't really seen myself. I have 4th edition. You can definitely find it online. But one of the most important book, the textbook, really the golden textbook for F equals to ma historically has been this text. It's known as Physics Volume 1 by Halliday Resnick and Crane. 4th edition, there's also 5th edition, which is like 10 times more expensive. But the 4th edition is, I kind of like the 4th edition because 4th edition is more of a comprehensive, meaning that if you're really studying motion, right, towards the end of the chapter, it also mentions the limitation of a classical approach, right, mentioning about this relativity, the modern approach. So this book is so easy to read and also easy to connect classical to modern physics. So that's just a very natural flow, right? But remember, these books are old and they're not really shiny or with a lot of colors and pictures. They're kind of dull. They're not like this book, for example, right? But at the same time, it's a very rigorous book, right? Students will definitely have hard time to solve all the problems inside this book. It's just meant to be quite challenging, okay? But the explanations and the chapters are very well laid out and they're really beautiful in that sense. So I would definitely recommend 4th edition. eBay, because it's not published anymore. At eBay, you can find it under $10. So this book, textbook, you can find it under $10. Next up, okay, as you can see, same textbook called Physics. Now they slightly see by the same authors, Halliday Resnick, but then they slightly did something else. They added fundamentals of, because Halliday and Resnick got very old, these professors, and then this publisher gave this authorship to Professor Walker, who kind of took this original book and then made it something else out of it. It just became extremely thick, and although it's easy to read, but they took out very challenging problems from this book. So this book is can be read and studied by just about anyone, but keep in mind that this book doesn't really have as challenging problems as these original textbook presented, okay? But still good, accessible text and physics. What else? One more for advanced students, I would really propose a secondary, right? Like a supplementary textbook will be by Professor Morin, known as a Problems and Solution in Introductory Mechanics. It's a beautiful book, but this is a little bit overkill. meaning that you'll be introduced to super difficult questions in mechanics, right? And then he will also present the solutions, but this is a little bit notch above the level of F equals to MA. This is just for very advanced students. If you want to go beyond the level of F equals to MA exam, that will be your supplementary book. Okay. And what else I wanted to say? So you can pick up any book, not this book. You can pick up, for example, this book or this book or this book, basically to study the chapter and come to the class a little bit prepared, so that now you know you have the fundamentals, so we can build upon that. So the way I'm going to be teaching is basically I'll just open up, try to summarize the entire content, the entire subject. For example, if it's motion, I'm going to go over from A to Z about everything about motion, and then we're going to dive into problem solving. Okay, that's basically how we're going to drill it. Meaning that if you are about to take an exam at a very short time, the best approach, the best practice is basically after quickly summarizing the text, after quickly summarizing the concept, the core concepts, the next thing is just drilling through questions and problems. So that's going to be my approach as well. Video recordings will be there available, and that's basically a textbook and our approach to the subject. So one thing I would like to really say before opening the session for the questions is this one: why you need to study for FMA. I cannot really emphasize how important this is, but the highest colleges right here in America, like all these elite colleges such as MIT, Caltech, and Harvard, and all of the other, they are very obsessed with students who participated in these exams, because it shows your caliber, it shows you how high level and enthusiasm you have for physics. They see that you love physics and you participated in it. Even though if you couldn't really get anything, like for example, even if you couldn't really pass it, doesn't matter. You can still put that saying that you have studied for and you participated in these exams. That alone is going to be very shiny line in your resume. However, if you really pass and then you join US team and then go, you're going to really meet all these like-minded, brilliant people. Right? These are the future of science. These are the best people in physics around the world. You're going to meet them, and I cannot really express my emotions how beautiful that experience is. Once you get to know these people and how sharp and beautiful mind they are, you will be just astonished. You will be just say that, well, this is it. This is my life goal. And that's how it started for me, really. And I cannot really forget those days. So that's just basically beautiful, wonderful. And after coming from that exam, right, from International Physics Olympiad, after coming, what happens is that all of these elite colleges will welcome you with their open arms, saying that you just come, full scholarship, everything, and you can just simply go to those colleges, apply, and you're going to really see it. Telling it from my experience, my students, who have really participated in this one, they went to MIT's, Caltech, and many other really universities, basically with a full scholarship. That's basically FMA, and this is what I wanted to share about our class. Let me go ahead and open session for the questions and any comments you would like to pass on. So for questions, you can just go ahead and unmute yourself any moment, and then let me try to answer.
So I got a question, like as a mom for 8th grader, what would be the prerequisites to take this course?
Well, the prerequisite on the website, Momentum tells that the prerequisite should be AP Physics 1. However, I would say that yes, that will be it. But if your student has a potential, right, and able to actually pick up a physics book and then read through and understand this background, understand these chapters, that shows the brilliance of your student, and they maybe actually can join it and try their best to see how they do it. So I would still recommend, with the condition that they have passion for and they have a brilliance of mind. Yes.
Thank you.
In the chat box, Tiger asked why rotational kinematics before momentum. Rotational kinematics before momentum, we can definitely switch back and forth, different subjects. But the reason we're going to we cover rotational kinematics or rotational dynamics before momentum is because in momentum we see angular momentum coming in, and angular momentum is about rotations now. So if you don't have the background in rotation, then it's going to be quite difficult to understand fully what the momentum is about. So momentum will be covering not only linear but also rotational. So you have linear momentum and you have angular momentum. For angular, you have to have a background in rotational. I hope that makes sense to you, Tiger. Okay, what else? Any other questions?
After F equals MA, like after the initial competition, is there a process to get to the US team, or is it just this is the qualifying exam and then you're automatically a part of the team? Like, what's the process?
So the process in the past, and I think it's the same thing, same still, is that once you pass FMA and you are finalist, you just get in, right? And then they are going to have a second exam that really covers not mechanics but also electricity, among other chapters as well. So yes, these students, this body of the students are going to be, having the second exam later, maybe a month or two, or probably 2 months or so. But then after passing that exam, they take you all the way to the training camp, the boot camps. And then over there, they train you. And then now you joined it. After passing the second one, you're joining this boot camp. It's going to be like a workshop. You'll be staying there in the dormitory or whatever the designated area will be. In the past, they used to have like University of Pennsylvania and among other places where they had all this team, and several professors will be really walking them. And these people they also had experience in the International Physics Olympiad. They'll be teaching them exactly how to approach the problems and how to do the theoretical part and how to perform the experimental part of the exam. So yes, there will be a training, and then after that, we'll be taken to International Physics Olympiad as a team member of USA physics team. So yes, there will be a secondary, there will be follow-up exam to basically boil down these brilliant people to 5. Okay, so I believe it's only 5 people who are going to be representing USA. So if you give me one quick moment, so exam date it's February 12th. That is the exam date, but I believe the registration is it open registrations? I think if I'm really not mistaken, the registration should be open. The deadline is January 20th. Registration is now open. You can definitely go ahead and sign up. I think your school should be signing you up because parents cannot proctor. It's going to be like online exam, and from school, a science teacher can do that for you, and you go there and just basically they're going to pay $75 to sign up, and then you're good to go. What else? So that's basically registration, and once you're there, that's it. You're going to be ready to get your FMA exam February this 12th from 1 to 4 p.m. And then the exact days time. So the International Physics Olympiad is going to be in Colombia and between July 4th and 12th. So basically you're going to have your passport, right, and really travel there should you join the USA team. And so here it is. Last year, 2025, the winner team, these are. And look at this, all of these 5 people, brilliant people, they got the gold medals. That's how it is. Once you make your way into the team, that means you are ready to roll. And given the final preparation, then you'll be ready to go and destroy and get your gold medal, bring it back. And that's it. Forever you're going to be famous, right? But it's not about the fame though. It's about actually having your passion in there. And then afterwards, you're going to be building on top of that, right? It's going to be your brilliant beginning. That's what I would say. All right. Any other question? Let's see. So there's in the chat box, is Algebra 2 or pre-calc prerequisite? Not. There is no prerequisite for this class other than AP Physics 1. Even that one we don't really impose. But Algebra 2 will be good to have because we're going to need trigonometry. If your students knows trigonometry, then we're good to go. Integrations and derivatives and integration. If you are able to actually your students knows those, that will be even more. That will be even better. But that's basically it. Algebra 2 with trigonometry will be really great to have. So one last question in the chat box. Other than homework and class time, how much time do students need to spend daily to prepare for the exam from the end of November? It depends. Of course, it depends on your experience so far. If you have taken physics 1, 2, C, like Tiger did, for example, right? You already have a good foundation. You have a strong foundation. For you, it's going to be just like fun time, sitting down and studying. Maybe you'll study for at least maybe 2 hours, at least 2 hours, I would say. But the more the better. Because remember, this is intense, and all that put together. Also forgetting kicks in as well. So not only you have to review past, you need to really learn the new things and then able to acquire the skills to solve the problems thrown at you. Okay, what else? That will be it from the text box, from the chat box. Any other questions?
I do have one question. So
Sure, go
because
ahead.
this is more like specific for the FNMA contest, right?
Okay.
So how you introduced a few books, but what contents actually you teach in your class for such a short time to prepare for this contest?
So in as a contest, so these textbooks I basically shared with students to have them, to have the access to those textbooks. So basically, if you have this textbook, that will be wonderful for them to study. But what I'm going to be doing, whether the students has access to those textbooks or not, we're going to go over these chapters one by one. Every session is going to cover one of these units. So motion, we're not going to open the book and then read it from the book, but I'm going to be right here, right over the Zoom with my tablet, pen and paper, right, pen and tablet. I'll be really introducing the whole concepts, key concepts, core ideas, all the equations we need. And then after that, we'll be solving from easy to difficult problems. And then we'll also dive to solve more of a FMA type questions, previous questions or similar type questions. So those textbooks for students, as a reference, because to have those access to these books is really important, I would say. Especially if your students are really young and then going to be having years to participate in FMA, definitely getting those books are going to be very helpful.
One additional question, sorry.
Sure.
So are those previous contest questions, problems, and solutions available online?
That's correct.
Okay.
So
thank you.
not all solutions are available. Sometimes our solutions are kind of vague. Sometimes just simply put the answer because this test is basically a multiple choice test. And given that, it's sometimes they'll just say that the answer is this, and you don't really get the satisfactory and in explanation why it is so. But here we're going to really take it one at a time and then expand the whole thing and then try to fully understand what it is with an attempt to get the skill, right? So we're able to solve not just that problem, but any similar problem, right? Any similar problem within the unit. And that's going to be our approach, basically. Not to memorize any particular solution, but acquire a skill set needed to solve problems in that subject area. Yes. All right. If no more questions, ladies and gentlemen, parents and students, I am very thankful for you to joining us this night. And I welcome everyone. If you have any questions, you can definitely reach out to Momentum. People, they will be, routing your questions to me, and you can definitely reach out to me anytime you like. I'll share my contacts with my students, my email with my students, so that they'll have the access, to contact me any moment, anytime they like. So with that, I'm wishing you a beautiful night and take good care. And then I hope to see, if not all, then at least some of you in my class. Goodbye, everyone.